Last class we have seen uh, that how static friction works, and also we have known about momentum conservation. Now in this class we will be talking about how friction plays a role for daily life. Talking about that, first thing we will talk is the sliding of a car when the car is trying to take the turn. Now a little bit revise for the last part. So we have told that static friction works for any stationary objects. Now if you want to push this object that side, the static friction will work at the surface of the interface and in the opposite direction. So Fs works in opposite of the applied force or the motion. And also you have seen this for that this force, frictional force, is adaptive. That means it can adjust with the applied force up to some certain limit. After that it cannot adjust. So this certain limit, the maximum limit, we told this limit as limiting friction, and we have seen that this limiting friction is proportional to normal reaction, and we can write mu s into n, whereas normal reaction n is the reaction given by the float to the block due to its gravity which was working down. So normal reaction is nothing but your mg, so frictional force you can always write as mu s mg, and we can do some of the numericals using this formula. Now talking to some real life situation, and I told you that now we are going to talk about a situation when a car wants to take a turn. So when we are looking from upward, we can see that, let's say this is the turn and the car is there. So let me draw a nice turn. So for this I will just a minute. So let's say this is the turn and the car wants to take this turn. So here is the car was going in this direction and it is taking this turn. The radius of this turn is say r. So when we look from side, we can see that this is the car. Say I am very bad at drawing, so just adjust. This is the wheels of the car, and this is that road which has taken a turn after some time. So the car when takes a round, you know that when something moves in a circular motion or a semicircular motion, that object experience an outward force which is nothing but your mv square by r, that is your centrifugal force. So this centrifugal force will always push the car so that it can slide in the outward direction. And you know this like if you drive any car very fast in some of the bends, so you can see that there is a huge possibility that your car can slide off the road. So we have to ensure that this situation does not arrive. So we have some velocity limit. So you can see that some places in nearby bend it is written that the maximum velocity is 20 or something else. So how do they calculate this velocity? So we are going to calculate this one. So we know that the centrifugal force which is acting that like outward away from the bend, so that is pushing the cars to go in this side. Now the question is that there is no other force which can counteract this force. Now if there is no other force to counteract this force, what will happen? Because of this force the car will rotate and the car will slide away or slips away from the bend. So there is a possibility of accident. So what happened? Because of the tire, you know that the tires are having very good grips. Now this tire, when this tire wants to go in outward side, the frictional force acts in the opposite side in such that so that the car don't slide up. So this frictional force must have to balance this centrifugal force. So if these two forces balances each other, we can easily write that for safe turning, this Fs should be equal to or greater than, so it should be greater or equal to. So if it is greater, then also car will not slip away, and if it is equal, then also the situation will be safe. So when this will be more than or equal to the centrifugal force, in that case the car will not slip away and the accidental probability is less. So we know that Fs is nothing but your mu s mg. So this mu s mg is the mu s is of tire and road. So this mu s depends on the tire and the road. Okay. So mu s mg should balance mv square by r. So if you cut m, so you can always see that this v must be less than or equal to our mu s rg ka root. So this is basically the equation which limits the velocity, that means the safe velocity. So this v, if you drive with a velocity which is less than root over mu s rg, then you have you will have a safe journey. Okay, so this is the situation when we have a flat bending. Now you know that this mu, so in this case only, if the r value is higher, so we cannot what you say, mu s value is not that much we can improve, because the tire is made of whatever material is having some mu s which cannot be greatly enhanced. So the velocity in the bends will be very slow, so there will be so much traffic jam in such situation. So we have some different arrangement for that, and we say this as bending. Now what is this bending is all about? Now in the bending you can see that some of the flyover, when you take a bend, you see that one portion of the flyover is really a little bit higher, whereas other portion is little bit downside. So when you take a round like this, you see that there is an inclination. So this inclination is there so that the car can move with higher velocity. Now how this inclination is helping, we have to see that. So this inclination means when the car is going like this turn, so we will see that this road, for this road, this side is little bit upper, so this portion is nothing but your this side, and this portion is nothing but your this side. So when we look from the side, we see this thing. Okay, that means one portion of the road is uplifted and one portion is down. So let us talk about how this bending can help the motion so that the car can be fast. So now in this case, if I have the car, so the car will be here. So the car is going, okay, and taking the turn. Let's say theta is the inclination or the bending angle of this road. Now you can see that my mg is working downward, whereas my normal reaction is given by the floor of this inclination, that means this floor is normal to the floor. so that means the n will be in this direction. So there is a what you say, this mg. Now in this case n and mg are not the same, and also you can see that this mg works in two components. One is this one and one is this one. So if this is theta, so this angle will also be theta. So this will be mg cos theta. So in that case one n will be equal to mg cos theta. Now how this is theta, we can see that geometrically. Okay, so we can easily see that this is theta, and we are talking about, let's say this is our mg and we are talking about this one. So this total thing is 90 degree, this is also 90. So if this is theta, so this one will be 90 minus theta, and the total angle is 90, so this much will be again theta, and that's why that one is theta. So you can do it. Okay, you can little bit do geometry and you can easily get this. And this one will be my mg cos theta, sorry, sin theta. And I can see that due to my mv square by r, what is happening due to my m, because there will be some tendency for my mv square by r, so that it can work, it can slide this what you say, car out of the road. So some portion of this, so the car is taking the bend, so my mv square by r will be in this direction. So let me clear it out a bit. So in this direction will be mv square by r. Okay, and this one will be my mg cos theta as usual. Okay, fine. So in this case my normal reaction will be mg cos theta. Now if I don't what you say, if I don't take the consideration of friction, then only mg sin theta is counteracting this mv square by r, but we have to take this component. Okay, now if this is theta, this will be again theta. That also you can do geometrically, because this is 90, and okay, so this will be my mv square by r cos theta. So you can see that in this case if I balance this two portion, so I can write that mg sin theta is balancing mv square by r cos theta. So I can cut m and m here, and I can get this g sin theta is v square by r cos theta. So from this I can get easily that my so I'm writing in this part. So g sin theta, I got v square by r cos theta. So from this I can easily get that v is rg tan theta. So I can get this thing here, that v should be rg tan theta if I don't consider friction. And if I consider the frictional force, so this is the bending without friction. So this is the velocity limit without friction. So we can see that now for a normal like value of theta, let's say theta is 45 degree, we know g ka value is almost 10, let me take, and r ka value can be like say a sharp bending. So for the sharp bending it can be 30 meter or so, and you can see easily one thing that let's say it is 40 meter. So you can see if I put the values, so this will be 440 into 10, that is 400. So my final velocity will be 20 meter per second. So this will be the limit. Okay, so in this bending there will be a caution board writing that the speed limit is 20. But you can seriously you can think that this 20 is very less, right? So in the earlier case this is lesser than that, because mu s is generally near to, like, very, it's very less. Okay, it's very less. So if you calculate this, v will be very very less. So in that case 20 is also less for the bending if we don't consider friction. But if we consider friction, then this equation will be modified a little bit, and this equation, that is vrg tan theta, will be modified also. So I'm doing here, if we consider friction, so let me say this is the inclination, this is my small what do you say, car, or let me draw it correctly, let's say this is the car. Okay. And this normal is working upward, mg was working downward, so this is theta, means this is theta, so my this one will be mg cos theta. My up mv square by r was working in this direction, and this mg is one of the component that was working in this direction is mg sine theta. To counteract mg sine theta, one component of mv square by r is working also, and this is theta, so this is mv square by r cos theta. And now we can take the friction. So see, this mv square by r cos theta, this will try to move this what you say, car upward, in upward direction, right, so that it can slip off the road. So that means the friction will work in the opposite direction of that motion. So friction is helping mg sine theta in that case. So I can write now mg sine theta plus friction is equal to mv square by r cos theta. And now you can see that if I write mg sine theta, and my frictional force is what, mu s n. Now in that case mu s n is mg cos theta, because it is balancing mg cos theta, so n is equal to mg cos theta in this case. You can see that is in one line, that means this n and this mg cos theta is in same line, so we can write here mg cos theta. So if I put here mg mu as cos theta equal to mv square by r cos theta. Now I can remove all of the m in all sides, and I can write that g sine theta plus mu s g cos theta is equal to v square by r cos theta. And from here I can write taking g common, so, and I can write sine theta plus mu s cos theta is equal to v square by r cos theta. And I can write v square is nothing but your rg sine theta by cos theta, because I'm bringing this cos theta that side, so it will be sine by cos, that is tan theta plus mu s. So I can write v is equal to root over this. So now you look at this one, that is rg tan theta plus mu s, whereas in the last case we have seen this is only rg tan theta, plus here but here this what you say mu s is coming again, and so yeah, so mu s is coming back in this case. So we can easily see that in this case, taking friction, uh, taking frictional, so if we take the frictional force as well, so we can easily see that this V is much larger than the V out here, which can be lesser. And in case of bending, that's why you have to go slow in order to like not to slip away. So this much is very important aspects of friction, that is regarding bending. And we can do many this kind of what you say problems regarding friction. uh, and what we can say, like let's say one kind of problem we can have, let's say we have a uh, okay, let's say I have a floor like this, and I have a pulley here, a small pulley, and also I have a thread here out here. So a thread is coming to this pulley, and it is going from here, and with this thread something is rotating, let's say. So let's say there is a block, and there is some weight or some ball of having some weight, kind of like say this is m2 and this is say m1. The frictional coefficient between this one is mu s, and let's say it is moving, like it is rotating like this, it is rotating like this with some of the radius say r, and let's say the what you say the angle here is theta. So you can now find out what is the what you say what is the, this is moving with some kind of velocity, right? So what is this angular velocity, safe angular velocity, so that this mass does not slip away from the table. So this is one what you say assignment for you, and you have to do this. So that is for today, and in our next class we will be talking about this kind of questions. So this is the assignment for you, and tomorrow we'll be discussing about this thing. So bye bye for today, and see you in my next class.